Tools been in business for over 70 years. We're blessed to have sell machines in 70 countries and over 1,000 customers. We believe that gives us a global perspective in regard to the heat transfer industry. In addition to that, what we're trying to do is bring more customized and local solutions to you specifically as the end user.
Our greatest desire here at Baroque Tool is to serve the customers and to provide them with the solutions that they need and to bridge the gap between what they need and then what we're capable of doing for them.
So our innovation strategy has to not only satisfy our customers' needs today, but be innovative enough to reach out into the future.
I'm excited for the opportunity to talk about innovation and more specifically about the newest project that Baroque Tools taken on. I think the best way to describe this or frame this conversation would be to use the thoughts of a great thinker on quality and management, and that's Edwards Deming.
It is not necessary to change. Survival is not mandatory.
That's a great way for us to think about always looking and improving our product lines and our processes.
Well, our overall vision for innovation is to make our new products so good that nobody would ever make a rational decision to purchase anything but a new product.
And so it's really important for us to experience what our customers experience and to really understand and know the challenges that they're facing so that we can provide for them the most effective solutions through our innovation process.
If we talk specifically about the heat transfer industry, there's been a couple of changes recently. In North America, many of the manufacturers went to aluminum tubing for the heat exchanger coils. And globally, others have gone to smaller and smaller tube diameters. Both of these changes have really created production issues in their processes. So one of Baroque Tools' ambitions is to address these issues and anticipate these issues.
So for us to really hit the mark on rapid innovation means that we need to launch things that the customers can use, that are useful. The technology for pressure expansion has existed in other markets, and that's something that we've been considering for actually quite some time. And applying that particular technology to this process for coil expansion made a lot of sense. Do a comparison on what we think we can do with the technology of pressure expansion and compare that to what exists currently with mechanical expansion. And we put that together in what we call a strategy canvas.
The list of requirements that we collected were based quite a bit on voice of the customer and their requirements for small diameter expansion. And then also from our customers regarding standard expander products like a non-shrink style expander or more control over the length and stick out control of the coil.
With mechanical expansion, you have serious issues that everybody that does mechanical expansion has. You can't push a bullet down inside of a tube without doing damage to the inside of the tube. That's especially true if the tube is enhanced. Mechanical expansion causes coil shrinkage. Now there's things you can do like grabbing the end of the tube and grabbing the end of the hairpin, and you can mitigate that some. But those are both bad things. Shrinkage is bad because now you got to buy more tubing to make the same length coil. Well, the combination of the Triumph hairpin bender, which doesn't have peg leg and makes amazingly straight hairpins, and the Phoenix expander, which doesn't have mechanical bullets, means you can take your scrap costs that everybody has in mechanical expansion and drive them down to zero. Because the Phoenix expander, as long as there's nothing wrong with the tubing, is going to make coils that just look like works of art. It's amazing.
want to be part of a thought leadership in the industry. So we've developed partnerships with customers, with other suppliers to the industry, and also the academic institutions. And specifically, we've worked with OTS.
Optimized Thermal Systems started as Thermal Analysis Partners in 2002 and changed its name to Optimized Thermal Systems in 2010. We specialize in providing engineering consulting for the design, analysis, and optimization of heating, ventilation, air conditioning, and refrigeration systems.
We worked with some good partners of ours. We were able to gain a lot of knowledge about the coil geometries and design and some of the things that are important to them. By doing this, we were able to change some of our design criteria to allow us to actually bring pressure expansion to fruition.
Recently, we've seen the industry continue to push the boundaries in heat exchanger design by exploring the use of small diameter tubes with an outer diameter of 5 mm or less. These tubes may also include inner enhancements, sometimes referred to as rifling, or microfins, or microgroove tubes. The geometry and structure for internal tube enhancements has, thus far, been limited by the manufacturing processes to make them. So when Burroughs Tool came to us with the concept of a high production capacity apparatus that would pressure expand a heat exchange coil, we immediately recognized the potential it could have for the HVAC industry in regards to the adoption of microgroove tube heat exchangers. A non-mechanical expansion process can enable further inner tube enhancements, even those that are more delicate or intricate than existing microgroove designs.
The Phoenix Expander encompasses a large quantity of our newest technologies. The ability to properly control pressure at nearly any flow rate to within a few PSI is quite impressive.
Going into this project, we had concerns about the pressure not being controllable enough to achieve a similar expansion diameter that we would see from a mechanical bullet. So we spent several hours and hours of validating the process in the R&D lab here at Burroughs Tool to find the perfect set point of pressure to achieve a comparable expansion diameter.
In order to meet the cycle time that we expect for this machine, we have to use a servo motion in order to control the coils so they stop at a precise spot at each station, and also use a servo control axis on the bell and flare system in order to be able to perform good bell and flare with the flexibility the servo gives us and the precision that the servo system can give us.
As with any new process, there's a lot of questions, and the first question that probably comes to everyone's mind is what happens when the coils do exceed their pressure limit. And this is, of course, the primary focus of our safety and validation plan.
We've designed it in such a way to use 3 levels of safety to keep the coil from overpressurizing. The first is to use devices that are rated for a pressure higher than the maximum pressure available in the system. The second level of safety is we do limits inside the software and the PLC and the safety controller as well. The third level of safety is we have a relief valve on each pressure manifold. So if we do end up having an overrun condition, the relief valve will exhaust any pressure above the set level in the relief valve.
On a conventional mechanical expander, the rods and tools have all been mechanically tied together. On the pressure expander machine, we've been able to actually separate the flaring tool from the belling tool.
This enabled us to specifically design tooling for a belling OD and a flaring OD. The tooling can simply be changed out to increase the flaring diameter or to lower your bell depth. Okay. By the way, we control the flare being added to the top of the tube, we can, by the turn of a knob, change the pressure that is applied onto the flare and make small adjustments on the fly to reduce splits. The best feature of the Phoenix Expander in my mind is the manifold design and how we achieve the clamping and sealing of the coil. We went to a sealing method that is independent from any oils, so no matter what kind of oils you have here, it'll clamp and seal.
From the control perspective, we tried to design the pressure expander to be easy to set up with easy operator interface and quick changeover between different coils.
There are many innovations that are in this machine that will make everybody that has this machine in their factory thankful that they have it. We have the ability to give you consistent expansion diameters with the pressure expansion process. We have the ability to give consistent bell depths as well as flare diameters independently. In doing this, we even have built into the process the ability to do tooling changes faster. We have the ability to have a failed coil easily removed from the machine and the machine put back in operation within just a few minutes.
To fully understand the potential and impacts of the Phoenix approach, OTS has been collaborating with Baroque Tool to test the heat transfer performance of coils that are pressure expanded versus those that are mechanically expanded. Results have proven that the pressure expansion process at minimum meets the same level of performance as mechanically expanded coils.
So if you imagine walking through your coil line, especially the expander area, and there's the elimination of bullets and rods and lubricant, and of course the big problem of variable shrink rates. Those problems evaporate, and it certainly makes sense to consider a new way of expanding. And we believe that we've got those issues resolved with this new Phoenix Expander.
Baroque Tool is a valuable industry partner and resource for us, helping to make next generation heat exchanger design a reality. We look forward to our further testing of the heat transfer capabilities of the Phoenix Pressure Expander, and are pleased to be partners with Baroque Tool as we together innovate to meet and anticipate the needs of the HVAC industry. This is not our first time working with Baroque Tool. We're impressed with their attention to detail and diligent efforts to conduct research relating to heat exchange and various manufacturing methods.
So we believe this enhanced process is really helping us in the industry. We've really changed how the small diameter coil production is going to be done.
All the rigorous testing and engineering effort we've put towards the Phoenix Expander makes us truly believe that this is an expansion reborn.
I feel that this technology is here to revolutionize the coil manufacturing industry because of the flexibility and the control that we have with this new machine compared to existing conventional expansion.
I believe, based on all the excessive validation testing that has been done here at Baroque Tool, that the Phoenix Expander will be an essential and indisplaceable solution for your current and future expansion needs.
As we look to the future, you can expect Baroque Tool to have a torrid rate of innovation. I expect that 5 years from now, we are not making any of the things that we make today. That we will have new and revolutionary products in all of our value streams that will enable our customers to be enormously successful in the things that they do.
Pressure expansion is absolutely the future for smaller diameter tube coils.